So multiplying longer polynomials, it's going to be fairly brief. I'm going to look at one example here. It comes from how we could group things together. The idea is, if I have a binomial, I'm just going to do it in general form, times a larger, let me get different variables, a larger polynomial, 3 terms, we can pretend that C and D are grouped together. And so we can distribute. And so we end up with A plus B times C plus D plus E times A plus B. And we can continue this process no matter how many terms we have. So our associative rules our associative property of multiplication and distribution property combine. But what we really care about is not the why, but the how in this case. So I'm going to make a very specific example. I'm going to have x plus 3. I'm going to multiply it by x to the 4th plus x cubed plus 5x squared plus 6x plus 1. Now instead of grouping everything through, we're going to take the end result of that, which is what ends up happening when you work your way through is you can think of each term, x, needs to multiply once to each term here. And the 3 does the same thing. I'll do it up above. Right? So we'll get it moving through each part here. And so this creates a lot of terms. So what I normally do is I start with x, and I go x times x to the 4th plus x times x to the 3rd plus x times 5x squared plus x times 6x plus x times 1. But I'm not done. The 3 needs to happen next. So you see how these expand really quick. So 3 times, let me scroll up, x to the 4th. So that's my 3 times x to the 4th plus 3 times x cubed plus 3 times 5x squared plus 3 times 6x plus 3 times 1. So I've taken each term one by one and multiplied it to everything in the polynomial. So this binomial has gotten multiplied by the larger polynomial. I'm going to change colors as I simply go to the next step here. So you get a lot of steps. So this becomes x to the 5th plus x to the 4th plus 5x cubed plus 6x squared plus x plus 3x to the 4th plus 3x cubed plus 15x squared plus 18x plus 3. So I did my multiplication simplifying these two lines. collect like terms, one more color change. So x to the 5th plus 4x to the 4th plus 8x cubed plus 21x squared plus 19x plus 3. That's a lot. But the process is repeatable. We take each term and make sure it gets multiplied by the other polynomial's terms one by one. So if I have a large polynomial, x cubed plus x squared plus 1 times another large polynomial, 2x plus, 2x squared, sorry about that, 2x squared plus 1x. Don't know why I wrote the 1 in my notes there, but plus 1x plus 3. The key, I start on the left, and I go, I'm going to take x cubed, and I'm going to multiply it by each one of these things. So x cubed times 2x is 2x to the 5th. X cubed times x is x to the 4th. And x cubed times 3 is 3x cubed. And I pencil off, I've done this. I've multiplied this through everything. Next, I look at the x squared, and again, x squared is going to have to be multiplied by each of the three things. So I have x squared times 2x squared, that's 2x to the 4th. X squared times x is x cubed. And x squared times 3 is 3x squared. Next, and they keep going, I have this 1. And this 1 is going to be multiplied by each of these terms again. And so 1 times 2x is 2x squared. 1 times x is x. And 1 times 3 is indeed a positive 3. And my last step is to gather like terms. So there's only one x to the 5th, so that's 2x to the 5th. I have x to the 4th here, and 2x to the 4th here, so that's 3x to the 4th. I have 3x cubed and an x cubed, so that's 4x cubed. I have an 3x squared and 2x squared, that's 5x squared. And I have an x and a 3 hanging out at the end here. And so that's how larger multiplication can work. I do it as I take whatever the first polynomial is presented through me, and I take each term and I multiply it across each term. All right, homework will be with multiplying and adding and subtracting polynomials so we get some practice on the math. And tomorrow we'll look at division.